All right. Good morning, good evening, good afternoon, and welcome to Going Meta Season 2, Episode 11. 2 years of knowledge graphs and GenAI. A recap is today's topic. We are looking back a little bit. I just opened up our library of episodes. The first one we did was obviously Season 1, Episode 1, and that was in 20, well, now it's gone again. 3 years ago, 1st of February 2022, we talked about Cypher and Sparkle side by side. That has now over 12,000 views. So thank you very much.
Wow.
It is started this series, started this season, made it possible for us to basically the foundation of us coming back every month and talking about all kinds of things. In the beginning, a little bit more on semantics, knowledge graphs, ontologies, taxonomies, RDF. In season 2, a little bit more GenAI, a little bit more knowledge graph still, and yeah, it's great to have you all join us every month. We've been very, I think, on time at least we tried. We skipped a couple of months, but all in all, I think we were there, and you were there as well. So it's great to have you join us every time. If you're a first time watcher, then welcome. If you are a long time watcher, special welcome as well. If you like the series, as always, please give it a thumbs up on YouTube if you watch it there. Leave a comment or subscribe to the channel. So that helps us keep the series going, and it shows the appreciation. Obviously, we're grateful and thankful that you join us today, and I'm happy to have you join us, Jesus. We are back again in August for yet another episode.
Yeah, right. Yeah, great to be here. I was reflecting exactly on the same. So it's true that the first, I mean, and this kind of recap, we think of bringing it round about similar time, like every time we've done like 20 episodes, right? It's not totally aligned with the seasons, but yeah, the first recap that we did was when we kind of change gears a little bit and move from the like you said, the whole semantics, ontologies, knowledge representation, a lot of RDF integrations, and yeah, we moved into this second kind of 20 episodes already. Yeah, nearly 20. I think it's like 18, 19, where we've been looking at without completely leaving this angle of semantics and ontologies and explicit semantics, basically bringing in, of course, GenAI. I mean, we couldn't have done differently, and I think it was a great moment to take a look back and similar to what we did last time, right? Try to group the many episodes that we've run in kind of categories, make sense of them, and like you were saying, for people who may not have attended every single episode, that can be of help, because that can give you sort of a map of what you can find and maybe where to go and find more details if you want to know more. And that's looking forward to that. So that's the plan for today.
Yeah, that's great. And I think we had good episodes, and we covered different topics across this season now, with a little bit going into the first one as well. And I think it's great to get this overview. I think the first one we had after the 20 episodes was particularly trying to recover what we covered, because we did so many things and we had so many topics, and it was probably a little bit difficult for people to find their way around these episodes. So it's great, I think, if we can do that again and help you find the content as relevant for you, depending on your interest. So yeah, I'll switch over to your screen here.
Excellent. Good. So so I would like to start with like I was saying, like a bit of a summary of the main themes that we've been covering, and then we'll go into, for each of the themes, to go and talk about episodes, and probably that will bring memories, and we'll have, maybe we can bring some highlights or some bits that we thought were particularly interesting about them. So the first one and the area where we started was with the foundations, right? So it was around the time, I mean, not when we introduced support for vectors in Neo4j, because we've had it for quite a while, since, you know, the when we were using them not to store text embeddings but structural embeddings, right? We had them before they became so popular in the context of AI, but we used that episodes to describe the first few ones to describe how capturing semantics in vectors is totally different from doing it explicitly in a graph, and how the two were, like I say, very different but very complementary. So we spent some time looking at that and going over the basics of RAG, right? Back then, I don't even think we called it GraphRAG. So we thought graph with knowledge graphs, right? Or something like that. But that was the very beginning, like how these two worlds kind of collide, or more than collide, you know, complement each other, right? How do you ground an LLM with a controlled, curated, and trusted knowledge graph in this case? So that was I would say the main theme, and of course that covers the first 2-3 weeks, and then from there we moved into all things about retrieval, right? So we had graphs, and we knew that combining the vector search with the graph exploration and some other techniques, we could do a pretty sophisticated questions back then. I mean, and again, we have to keep in mind this is 2 years ago. Probably we're doing some kind of basic one-shot interactions with LLMs, right? So we probably went, asked the question, did one retrieval step, and produced an answer, and that was it. But it's true that this retrieval step would include different techniques, and we'll go over them because we touched on a number of those. But then we kind of went on a tangent for a couple of episodes at least, where we thought, hey, what if we have structured data, probably in tables, and we want to build a graph model, and that's been a theme, I think, over time for both of us, right? So one of the main hurdles or obstacles that users face when they want to use graphs is, hey, my data lives in files or in a database. How do I get started? And we explored how LLMs could act as assistants for domain modeling, right? How do you come up with your first graph model in the first place, and then move your data into the graph? So we looked at that with specifically with structured data before going into the actual, you know, construction out of unstructured data, well, mixed data really, because we were using both structured and unstructured, and how we could throw ontologies into, or target schemas, however we want to call it, into the game, and even how do we even not provide it, but try to find which is the relevant schema out of a collection, out of a catalog to use depending on the case. So we did I think that's probably the richest area, because we spend up to, I would say, half a dozen, but even more episodes on this.
So, and I think we spent a bunch of these episodes there on the topic, because it was such a rich topic. It was when we touched it, I think at the beginning when you mentioned it, LLMs as assistants for domain modeling, when we talked about this, I would even say we were one of the first probably to talk about a concept that is now everybody knows about, agentic AI. Everybody talks about agentic AI. I think we didn't call it agentic AI back then. The term maybe wasn't even so popular back when we talked about it. But in essence, this is what it was, and then we had all these ontologies, help, knowledge graph construction sessions, where I think it's a particularly important one, an interesting one, for two reasons. One is that it's much easier for you to get started, because you already have a structure, which for unstructured data is not existing, and makes it much more difficult to organize your data. And then if you have that structure and you continue with adding unstructured data, but still you have an organizational pattern, I would say, that sticks around, and that helps you manage your data, your your process and your results are much more streamlined and much more consistent across your work.
Yeah. I would even be more radical on that. I mean, to the point at which you should not go and build a knowledge graph without the guardrails that a well-defined schema or an ontology provide. Otherwise, it's going to be unmanageable. I mean, probably for a quick demonstration or something like that, you can do that. And maybe that, it's true that there are cases where you're in purely exploratory mode. I have no idea what's in this file. I'm going to produce a graph and then I'm going to explore it, navigate it, and see what. But in the general case, if you're building a graph that you want to query, that you want to build logic on, that you want to build analytics on, I think it's a prerequisite to have a target schema that drives this construction and that then controls the shape of your graph to some extent. So I think that's a key best practice in this process. So I agree with you on that. And yeah, we'll talk about all these because we looked at it from so many angles. And then there was a final one. I mean, I put like a one-offs because I didn't know what to put it, but we spent a while ago when again, this is probably a year and a half ago or something like that.
This was a long time ago, yeah.
Data World team put out this benchmark when they compared the quality of the queries and basically the responses that an LLM was providing when you put your data in a relational database, or when you overlaid on top of that relational database a knowledge graph. They were using, of course, RDF, and so I wanted to put it in the context of our stack Neo4j. And what that meant, and we took a couple of examples of the rules they implemented and built them in Neo. I think that's an interesting one because it's a pretty popular, still quoted often, but I think it kind of because if you think of it, it's pretty obvious, right? And that was our main thesis in that episode. So if you give an LLM, now that we're familiar with structured query generation, cipher generation, SQL generation, if you ask a question in natural language to an LLM and you give it a description of the schema, in their case it's a relational schema, so a description of the tables that the schema has, maybe the LLM will do a decent job at producing some SQL. The quality might not be great, but what's obvious to me is, and that's natural, right? Because in SQL, when you have a table representation, you've made a number of compromises in the sense of you've translated your domain model, your entity relationship model, if you follow that approach, into a physical model, right? So you do things like, well, if there's a 1-to-1 relationship, you probably will bundle these into even if they represent two different entities, you will put them in the same table. If it's a 1-to-n, similarly, you would have a foreign key, so the relationship is kind of hidden there. If you have a join table, a many-to-many, you have to introduce a join table. So you kind of you complicate in a way the model to accommodate the nature of the relational model. So if now you put back this kind of domain model, well, the LLM is going to be able to generate much better quality questions. But the problem with their approach is that it was in terms of construction, it was pretty tricky because you have to have this kind of graph model, you have to have the mappings between this graph model and the relational model, you have to generate. In their case, they were generating Sparkle. The Sparkle needs to be translated into. So it was complex, and we looked at how we could take the rules that they have defined and just use them to ingest the data into Neo4j, and then you could do in one go the same thing, but a lot simpler. But so that was the kind of intuition. If you talk to a graph, to a model that's way more, closer to your understanding of the world, of course, the LLM is going to do a much better job at generating higher quality structured queries, and that's what we did in that episode. So, but yeah, that's a good one. So let's dive into each of the categories, and maybe we'll comment in more detail. So the first category is these kind of foundations, right? And that was back in episode 21 in series 1, where we talked about what it meant to capture semantics. It's overused term, and we wanted to explain what I don't know if this is readable, but it's meant to be just a kind of a tag, a mini card. You have the reference there, so we. As you know, I don't know if you mentioned, Alex, but all the episodes are available in our GitHub repo, so you can link to any episode, to the recording, but also to the slides that we used, and to any assets that we used in the session. Like that would be code, that would be data or ontologies or anything basically that we used. And on that one, we basically went over how can you capture semantics meaning, right? And you can do it in an explicit way in a graph, or you can do it in a more opaque, more implicit way in a vector. And both have advantages and disadvantages, right? So probably building a graph is harder work, but then it has lots of benefits, like the explainability, right? And the richness of the fact that you can explore it. The vector-based approach, and now we're talking about text embeddings, is great in the sense that it's very easy to build, right? You take an embedding model and throw at it whatever you want, a text in our case, a transcript of a video, or even a document or whatever, and it will generate a vector that has this magic behavior, right? That if two vectors are close to each other, topologically, as in Euclidean distance or angular distance, it means that these two things they represent are related to each other semantically. And that's great, because that will make it possible for to do semantic search. It's very robust. But the problem is you cannot really explain. These two things are close to each other, and I can't tell you why, because my LLM or my model said so.
Yeah.
And again, the thesis is, let's bring the two together, because they're highly, complementary, and because we're lucky to have support for both in Neo4j, we explain how these two things could be combined. So that was I think probably the first episode where we kind of dived into these new territory, right? So
yeah, I would say so. Yeah, and it was one of the foundations is a great word for that, where we said, okay, yeah, here you have these two approaches. Look at these. Look and judge for yourself, and decide what matters, what makes sense, and why would you use the one or the other, and what are the benefits and the advantages of doing so. So I think it's still relevant. It's still needed. I think it's still something that probably most people have now understood or have in their mind, but still without these we wouldn't be talking about knowledge graphs as much as we are now with this whole GraphRAG agentic AI environment. I think it's all based on this major difference that is everything is basing on.
Yeah, totally. And then from there we went into, well, let's see how they actually get combined, right? Because in Neo4j, the way we use vectors is we can store them as properties of nodes, right, or relationships, right? And then we can index them. We have a support for vector index, and what that means is that you can do a vector search on a vector index, and that's an approximate search, in the embedding sense. So again, Euclidean distance or angular distance, although in this case it's probably implementing approximate nearest neighbors, which is what most vector indexes implement. But anyway, what you can do is you have a question, you do a vector search, you get a top n matches, and because these vectors are actually connected to nodes, you can immediately dereference them and then contextualize and use that. And that's what we did in episode 22, right? So what does it mean to combine these two things? How do knowledge graph improve retrieval augmented generation? Well, they help you contextualizing, they help you re-ranking, they'll help you filtering out. So they basically help you move from pure semantic similarity to actual relevance, because similarity sometimes is not necessarily the most relevant results or the most relevant answer to your question, and this kind of exploration that you can start in this type of retrieval gets you exactly that. So exactly. That's
and I think you said something very important at the beginning here when you said two things might be similar, but even if you know that these two things are similar, but what does it give you? Nothing else. If it's just the similarity, then it's lots of guessworking involved. And so, okay, I know that these are similar. I don't know why these are similar. I don't know how they're similar. I have no idea, but I take these two because they're similar and I make something out of it. And then I as an LLM, I guess, I'll come up with some kind of answer and hope for the best. If I know why these are similar, if I know why they show up, and then I can assess at least, okay, these are similar because of this reason, and maybe this reason is completely going into the wrong direction of what the initial query was, then I can even discard these answers, or I can say, okay, yeah, now I know why these are similar, and then because of the context, I think this is still I think for me, when I look at this and I talk to people about this is the major difference, and this is the eye-opening moment where I say, okay, yeah, I understand now why similarity is fine, but it is sometimes still not enough.
Yeah, absolutely. So the contextualizing is very important, because we're going to go into the next step in a moment when we say, because let's say you have a rich document, a complex or long document, probably you will not generate just one vector, and there's this notion of chunking, right? You will break it down in parts, and yeah, you might have, if you do a search based on the vector representation of each of those chunks, you might get one match on a portion of the document, but interestingly, a relevant bit that complements the answer happens to be in a chunk that's not as relevant, but it's still related. So if you don't have these explicit connections saying, for example, this chunk is followed by this other one, or if it's a richer hierarchical organization, like a chapter has sub-chapters, and each one is one of the chunks, so you know that you should not take one in isolation, you should take the whole to provide a richer, more complete answer. So these explicit connections added to the vectors give you not just, the context, but in some cases even the ability to provide more completeness, more complete responses. So yeah, that's exactly the idea of how these two techniques are so complementary. So yeah, we moved from these foundational couple of episodes to explore what these retrieval patterns look like, and one, we've been talking about it already, right? So it's this idea of, I enter with a vector search, and then I navigate to whatever's in the neighborhood of that thing, and we can use the schema, we can use the attributes, the properties, relationships in the graph to drive that navigation. So that's basically the combination of vectors and traversals through the graph, which is the basic approach that we've talked about. But then we kind of enriched it and said, hey, what if we throw ontologies into the mix, right? And that's what we did in episode 24. Because the thing is, sometimes this contextualization can be of two different, can happen in two different ways, right? So you can just go out a number of hops away, like saying, whatever I land with my vector search, go 2 hops out and get anything in the neighborhood. That's entirely blind search, purely contextual. So whatever's in, or I can be more explicit and say, well, if I found a product, then go to the category or to the users that purchase it, or to whatever. And then in that case, you're more specific. Probably you get more more detailed answers, but you're kind of bound to the schema, because the moment you write a query, if what you find happens not to be a product, this is not going to expand the way you expect. So sometimes you want to give some flexibility, and depending on what that thing is, do one type of exploration or another. And that's what we tried with when we threw ontologies into this approach, right? So it was kind of a way of dynamically determining the type of exploration that you would do depending on what or where you land with your vector search. So that's what we tried in episode 24. So and then in season 2 episode 6, we compare different retrieval methods. So we took that, because we spent most of the time in the first episodes on looking at this, which is the kind of unique about Neo4j, right? The combination of vector plus graphs plus traversals. But there's other types of techniques. Sometimes you can do You can leverage also, full text search, which is another of the indexes that Neo4j supports, or even geospatial. You could, why not? You could do a geospatial search and then navigate, or you could do just vector. So, or you could even try to generate some cipher on the fly, because we have a text to cipher model. So the powerful thing with Neo4j is that you have a very, very rich collection of retrieval techniques, strategies that you can apply depending on the case. And that's what we explored in episode 6 in season 2. So we looked at, in particular, how they were implemented. I believe it was with the GraphRAG package, which is the one built by our engineering team. So, and well, yeah, and the last step was when we took it, you mentioned the agentic approach, right? So sometimes, and the way we build AI applications these days is probably being a bit less one shot, like go translate the query, generate some retrieval, and then produce an answer. It's more like there's n ways in which you can retrieve, and I'm going to offer them as tools or functions, depending on, we've called it in different ways. And then an agent, kind of a reasoner in a way, component, which is an LLM, will decide based on the question that's being given, well, I'm going to use this tool, I'm going to use this other one, because what you're asking me requires these or require. And that's something that they do autonomously. And that's kind of the idea of agentic behavior. And we looked at that in episode 7 when we, we always like to take it a bit, go meta, and rather than defining, hard coding 3 or 4 or 10 tools, maybe feed them through we used an ontology in that case, right? So we loaded that into the graph, so we kind of have it stored as data in the graph, so we can keep adding dynamically new tools without having to basically recompile the code or redeploy the code. So but the idea was, again, taking even further this idea of retrieval, right? Offering multiple techniques and leaving the agent to determine which one to use depending on the case.
Yeah, and it is really great to see how much that has picked up, and how much of a, I would say, almost a pillar it is now become for working with AI. So I think it was, I don't know, visionary maybe, but a little bit definitely one of the earliest approaches there for this.
Absolutely. So and what did we do after looking at retrieval patterns? So we went, yes, here's where we looked at the modeling step, right? So we in most of the previous cases we kind of, I wouldn't say we overlooked, but we thought there was a graph already there, or we build the graph and then we start from there. But then what about the whole, construction step? That's complex. It's complex. That can be an obstacle for people who are not familiar with graph modeling. So we looked at the possibility of having LLMs being our assistants to do graph modeling. And in episode 25, because we have this rich collection of data sets in what's it called, this Kaggle, right? So there's typically, mostly in CSV files or relational database exports, right? So what we were wondering is, okay, I'm given a let's call it an export in the laziest form, like a big denormalized table, a big file with 70 columns, right? So you have everything combined there, and you may find customer information, product information, address information, so lots of things in the columns that we would make sense as humans reading the headers and making sense of them. Or even, it's interesting because we discovered there, I hadn't seen it before, that Kaggle uses this interesting format that they call croissant. Remember?
Yes, I remember.
Formalism to describe, in a bit, provide a richer description of the structure of the data set, and for each of the headers, it would provide probably the data type, a description. So that was pretty useful when we want to make sense of it. So especially if the header name is price _1, what does that mean? Well, sometimes or you know how bad we are sometimes at naming things, and when we, especially when we evolve models, we may not be very careful of who's going to have to consume them afterwards. So this was useful because it gave us a nice description that, yeah, like I was saying. So what if we, given that description of the structure of a data set, what if we throw that at an LLM and ask the LLM to come up with a graph model out of it, and maybe detect the fact that there's, customer data, address data, product data, and maybe it will be able to tell us, well, that's one type of entity, customer. There's another type of entity, the address, where the customer is connected to. There's a product, so probably there's a purchase of this, customer purchasing a product. And how good would they be? And I have to say that we were quite impressed by the result, right? So that's what we did in episode 25. So and then the great thing is that we proved it by, well, now we have the model that the LLM has produced. Let's ingest the data, and we got a graph according to that model, and they were pretty good. I think most of the times we've used OpenAI, which I think it's still at the top end in that space, but that was great. I mean, I was pretty impressed by the ability. Of course, there's all the considerations, and I know some people might get a bit nervous when they hear that we're kind of delegating modeling, because of course there's the whole idea of consensus, and you don't model for yourself. You typically model in the context of an organization. You have to understand what type of workloads, but you can throw all these elements. And again, we refer to these as assistants, right? Not fully automating, which we could, but we call it as an assistant, where we still want to be in the loop and validate, right? And actually, that's what we did in episode 27, right? Because what we did is we implemented this first agentic workflow, right? Where we said, one LLM acts as the expert modeler, and then another LLM will act as a critic and say, hey, why did you model these, the address as a property of the person instead of extracting a separate node, or any kind of thoughts? And if you kind of iterate and you provide feedback, then the other one remodels, and then you provide feedback again, and you say, well, after 3 iterations, we're happy. Again, the quality of the model becomes even better, right? And that's what we did in that one, and I think that shows definitely a path forward. And it's
definitely that's definitely something I think that people will be using. I think we heard at Notes last year, when during the keynote, I think evaluation was one of the topics where I said, okay, it's difficult to find evaluation tools in the AI space, and lots of things have been developed in the meantime, and most of these are actually also LLM or AI based. And I had talked to Tomasz Bratanic the other week about his book, Essential GraphRAG, and he said LLM as a judge, or evaluation via LLM, is one of those things that he thinks is crucial when building with AI, because it is so hard and so difficult to write proper evaluation and testing with AI, because it is fluctuating in their answers. But it is something that helps you define what you want, and what you get should be in this definition, and should be getting in your results. So what we basically talked about here, this LLM as a judge kind of theme, is one of those pillars, again, I think, that is relevant for people. If you build something with AI, you should at least build something like this in your stack.
Yeah, I totally agree. And if we kind of accepted by now that code generation is one of the strongest, abilities of LLMs, and makes sense, because they've been trained on all the code that humans have written, or most of it. They've looked at everything that's on GitHub. I think the same applies to models, and they probably have consumed and explored all possible relational models out there, all possible, even the queries, even SQL queries, probably more than any others, because this is the most popular one. But I, my thoughts here, right? And it's not even my thoughts; it's like the evidence, the empirical evidence that I took out of this experiment is that, you remember how after running this episode, I got my team together back then, and and we did an exercise, right? We took, I shared a Kaggle data set with them and said, well, let's go model it and create a graph model. And we were all, I mean, I think we could call it ourselves, graph experts, right? Because that's what we do for a living. And of course, none of the models were identical, and that's the nature of it, right? So, but there was some kind of expertise implemented in this approach. But then I had, of course, these prototype that we created in episode 2027, and these came up with another model. And the reality is that model was indistinguishable from that of an expert. That was, of course, you have to take this with a pinch of salt because it was a small experiment. But the reality is that it's such an articulate approach that and yeah, I think that's definitely a way forward here, and something that we'll see a lot more in action. And well, it's not been long. We've seen how our product has integrated that, right? So in Aura now, in the data importer in Aura, you can point at a collection of files or at a collection of tables in your database, and you can use the magic button that will come up with the model itself, right? And of course, you validate and you approve and you discard elements that you don't like. But LLMs do a very, very decent job at applying this kind of reasoning and coming up with a decent quality model of the data in the form of a graph that then you can use to import and migrate your data into Neo. So that's I think that's definitely an interesting area where I really
especially I think when you think about it, you as the expert of your domain, you can roughly, I would say, stretch what your model should look like, and you can go into like, okay, this is an overview of the probably most likely outcome of a model that you would think of. And then if you have that and you take that and then throw it in and say, okay, but now go down to all the details that you don't have maybe, or you don't think of in at some point. And then you have an LLM and say, okay, here's all of the data and here's my rough outline of what I want it to look like, and then make a model that goes into that direction, and that includes all the steps down the line, because you can go down and can branch out, and then I would say you probably get something very, very robust from that.
Totally. And again, back to the news. I mean, we keep hearing that. Where is it? Like, I think they're at 30% or something like that. When we hear like Google's, publishing that 30% of the data that they produce is machine generated. It's like LLM generated. It's by AI. So I don't think we should be far from that. Even in the data modeling space. I mean, I would expect there to be that level of adoption and usage. So, but we'll see. That was definitely a fun experiment. I enjoyed that episode. I like that one.
Yeah, and it's a good invite to everybody else. I mean, if you have data, if you have structured data or unstructured, doesn't matter really. If you're afraid a little bit of starting your own data model, or maybe if you have one and then you want to see validate what you come up with, or vice versa, validate what the LLM comes up with. I think it's always good to, it's the easiest and probably cheapest way of getting a second opinion on anything these days.
Totally. So yeah, and then we moved into the knowledge graph construction, which is where we've spent loads and loads of episodes because we looked at it from many different angles, right? So we started with the most basic and no code approach, and we've still have out there the LLM knowledge graph builder, which our teams have built, and it's a great again no code environment to run some simple knowledge graph creation out of unstructured data. So that's the first experiment that we run. So we took some web pages. I think this was a data set about these plaques in London, right, where this famous person has been living here, and we used that data set to try and extract a graph out of it. And basically the idea, what we wanted to test there is, again, we talked about that a minute ago, is if we do a blind extraction, you will get a crazy graph. I mean, it will be a bit unwieldy. You will not be able to query. But if you introduced, and I think in that case, we looked at schema.org, some common terms like the notion of a person and some of the attributes of a person, the notion of an event or of a location. But we introduced some kind of standardization of the terminology, basically, which is a way of introducing an ontology, or a way of defining a target schema. And we saw how the quality of the graph became a lot more manageable and a lot better. So that was the first one. And then we do exactly the same, but programmatically, right? So once we've seen how that works visually and clicking through the knowledge graph builder, now let's jump into the code. And most of the times we've used the GraphRAG package from our team, and very similar. I mean, we can inject, of course, into the graph extraction, the entity extraction. I mean, it's probably worth mentioning here, although it's we do in every single episode, if you go to any of those, that the way, and I think that's quite unique as well, the way in Neo4j create a knowledge graph out of an unstructured data is kind of this dual approach, right? Where we have we look at the document graph, or the lexical graph, sometimes we call it, which is just looking at the structure of the document that you're parsing. And in the simplest case, it will be if it's just a text document with no structure, it will be, you will define how to break it down in chunks, right? Maybe by length or by paragraphs or whatever. And so basically, it will be a sequence of chunks, right? So there will be a fragment of text followed by another, and we represent them as nodes, right? So you have a representation of the structure of the document. If your document has a rich structure with chapters, and chapters have sub-chapters or definitions or sections, you might have a kind of a tree structure. But basically, this is kind of the foundation, which is the text in your source data, so the document graph. But then we do entity extraction, and we identify, I mean, the LLM does, identifies mentions of individuals or proteins or locations or whatever your domain is. And we represent those as nodes, and we kind of overlay the document graph with that. And we link it back. We say in this chunk, there's a mention of these entity, and entities are related to each other. So we extract relationships as well. So ultimately, we have a dual graph that has the document one and the domain graph, which is the more traditional one, where we see persons, objects, locations, events related to each other. And what that gives us, if we go back to because ultimately we're building the graph to do mostly retrieval, to build agents, to do conversational experiences. So it gives you multiple paths for exploration in the retrieval step. So if you do, as we were saying before, vector search, you might enter through the document graph, and then you navigate to the entities and contextualize and navigate and re-rank, filter, like we said before. Or you might be able to generate cipher, depending on the retriever that you use, over the domain graph. So that construction is driven by, and it's the default behavior of the GraphRAG package. And we experimented with that in episodes 2 and 3. And very importantly, we always do the kind of the target schema in the form of an ontology. And we always, of course, connect with the semantics world, right? So when an ontology is described in OWL or whatever, and it comes from Web Protege or whichever your preferred ontology modeling tool is, we show, and it's in many of these episodes, how this ontology can be used to drive the knowledge graph creation. And that was one of the main topics that we kept repeating at different stages in this construction from unstructured data.
Yeah, no, that's a great way of doing it. I think still, this is if you look back at these episodes, if you are starting with this, or if you are wondering how to do it, this combined approach that we showed there is really, really beneficial to your outcome. So I would definitely recommend looking at these episodes and getting some inspiration from how we showed it to you doing it yourself in this way.
Yeah, and the final part, just to complete the picture, is we looked at the from unstructured data, but our value proposition is we call it mixed data. We combine structure and unstructured into the graph, and we looked in episodes 5 and 27. I mean, a number of them. You see the references there on how to do that from structured data. And I think in episode 5 in season 2, we specifically use a single ontology to drive both the entity extraction from a number of files, PDF files, but also as a way to drive the construction from structured data out of relational tables, right? So so that's I think that's important because it shows again that the domain model, the ontology in this case, it drives the construction from both angles, from the non-structured, but also the structure. And it's what we mentioned before. The difference here, because remember when we talked about the Kaggle example, there we didn't have like a target ontology. We were kind of distilling the ontology from the data. In this case, what we're doing is more like mapping, right? So I have an ontology, I have this data, and how do these two things map? And in some examples, we used a manual approach. So in Aura, you can do that. So if you get the ontology on your screen in a visual representation, you can then drag and drop or say this table populates that node, or this table populates that other node. Or you can automate that using LLMs, which are very good at mapping as well, and ultimately generate the code. But that's very similar. I mean, similar but different, right? Similar. I mean, when you import structured data, is more of a structural mapping. So it's traditional ETL. It's like saying, okay, this table is going to go here, and you're going to use this column and this column. So it's more kind of rule-based, like matching structures, tables, columns to nodes. Whereas in the unstructured space is like, well, go scan there and find things that might fall in this category. And it's kind of a more, less deterministic, of course. And that's where you probably have to complement that with some kind of guardrails, some kind of shapes that control what you're producing. But yeah, and finally the last one is the same, but we keep combining the more manual, visual, no code with the purely programmatic, which we show in different episodes. So I think that's it. I mean, we've kind of covered all of them. I don't know if there's any question that we might want to.
Yeah, I'll have one remark which I wanted to point out, is that we often talked about the coming from unstructured data and importing that and working with that, and I think part of it is because it's really fun to do that, and it's really interesting to work with that, because you get something immediate in your response, and you see something that is usually or hasn't been very accessible in the past, and now all of a sudden you can make sense out of that. Those bunch of emails, those bunch of PDF documents, those bunch of meta information for images or video transcripts or whatever you have, and you couldn't really make use of that, and now you can, and then all of a sudden it makes lots of sense to you, and it's cool, and it's interesting, and you can play around with it a little bit. But what we forget in this process, because it's fun and cool, is usually you don't start there. You don't start with a bunch of PDFs. You start with some kind of structured data you already have, and it is, maybe it's an Excel file, maybe it is a relational database. Probably it is a relational database, and you have something like that already available, and from there it's much easier to map against.
Oh yeah, I mean, structured data provides kind of the scaffolding. I mean,
exactly.
the foundation in a way, right? So if you, and that's exactly what we did in, I think it's in episode, which was the one where we combine, it's episode 5, right? The one ontology to rule them all. So we loaded. If you remember, it was an e-commerce type of scenario where we had, I think the unstructured data came from PDFs that were like, were they something like, I think, were they like refund notes or something like that, right? So it was like
Yeah.
you purchase something, you return, and they produce I think it was like a PDF that contained the description of why
Oh yeah. Why
it
you
had been
returned it and
reimbursed or something, like credit notes or something like that. Anyway, and there were even product description, like in the form of a PDF. But again, if you have in a product description, you will probably have a mention of the product. You will have a mention of the parts, or maybe how they, some recommendations on how to use it, whatever. But if you can align that to, for example, a product catalog that typically will come from a structured
that will already
code.
exist, right? You already
Exactly.
have that.
You have these guarantee that you're not kind of running on that you have this sort of foundation in a way that you're aligning to a known set of possible values, which is your reference data, in this case your catalog. And yeah, we definitely recommend, whenever customers are working with unstructured data, to have some kind of reference to be able to link it to, so that it provides an additional code of data quality, if you want.
Yeah, sure. We had a couple of questions, so maybe let's talk about those. I think back when we talked about LLM as a judge, or LLM as a data modeling expert, or at least as a helper for that, Tertiary wrote a comment: is share all the data, refine to remove the noise. I think that's another great example of how it can help. I mean,
and that reminds me of one important thing. So we haven't talked enough about post-processing, and that's very important. So sometimes, yes, if you build too strong constraints on the ingestion part, like this is my schema, and anything that doesn't fit in that schema, throw it away, because I don't want to. It's going to produce a very clean graph, but you might be losing some information that's potentially relevant. So what if you give some degree of freedom in that process? So you have an ontology, but you accept certain things that might diverge from that ontology, and then you maybe post-process or refine or remove noise afterwards. So yes, I mean, I don't want to be like too dogmatic about it, but definitely we definitely recommend the use of an ontology to drive the construction. But sometimes you want to enrich it, or to add additional techniques like this one, maybe give some freedom and then post-process or filter out, or absolutely. So that's the space is too rich to have a single approach to it.
Yeah, definitely. Another question, or a comment rather, from Ramona. She says, what I find challenging as results that look almost correct, and we are quick to accept it. LLMs can easily change course into strange directions. Yeah.
Absolutely. That's the nature of LLMs, right? So, and that's the hallucination element is exactly that. Is they will produce something that's plausible and often right, but sometimes it will be completely invented, completely generated, and catching those cases, is key, and that's how you introduce these guardrails and these kind of agentic approaches. But yeah, ultimately we're never going to be safe from these type of situations, and that's why I think we're far from having LLMs being our doctors and things like that.
Hopefully.
but yeah, no, that's absolutely. So all we can, I mean, and they keep improving and in a number of ways, but that's what the sort of agentic approach tries to overcome, right? Putting all sorts of guardrails and protection around these kind of situations.
Absolutely. Yeah. And I think another comment here, I can just, Tertiary wrote, ontology is a big keyword if you're taking notes. So I think, yes. I think
if we did how do you call it, like a word cloud of the words that have been said in this episode, probably ontologies would be a big fat one, in the sense.
Yeah.
A lot, but
yeah.
True.
Yeah.
But I hope it's not because my whole intention, and when we talk about it, is like to sometimes demystify, and sometimes, I don't know if intentionally or not, people tend to think of it as something very arcane or something complex, and you have to take a very pragmatic approach with it, and we I think that's been the idea with these episodes, and I invite everyone to go have a look and see how we just create them and get value from them and grow from there. So that's always a very iterative approach is our method.
It's the goal. Yeah. I was meaning to get the next stream up here, which already is scheduled, but I couldn't get the slide to load. So I just want to say it here verbally. On the 12th of August, so next Tuesday, I'm having Arthur of G.V as a guest, and we talk about their Graph Native IDE. It's more like it's inspired by tools like the MySQL Workbench, if that is meaning anything to you. So it's a workbench type of graph development environment, which makes graph development easier. So we'll talk about this next time. Nodes is coming up, so if you're interested in that, join us in November. And if you want to learn more, if you want to see more, Graph Academy is there for you. Graph Academy has knowledge graph learning courses as well, if that is interesting. Neo4j Aura Free, like we mentioned today, is a bunch of things you can try there already. And if you want to know more, community is the place to go for all things Neo4j. To build.
Can you remind me when you said November for nodes?
Oh, in November, yes. 6th of November is when we do nodes itself, and we'll do a road to nodes workshops building up towards the November event starting mid-September. Once I have all the details, I'll share those with you as well. But they will be obviously about knowledge graphs, about GraphRAG, about Agentic AI. So it's gonna bridge a gap between now and November. Yeah.
Excellent. Looking forward to that one.
Looking forward to that. Yeah. We're taking a break with going meta in September. So FYI, we'll skip next episode, but we'll be back in October for our next edition. First Tuesday of the month as usual. And I hope to see you then. Take care. Have a good August, good summer, where it is nice and warm. I'll see you soon. Give us a comment or anything in the community forums or here on YouTube. If you like this episode, if you want to talk to us about a specific topic, then we can try to see if we can include that in one of the future episodes. And
excellent.
Thank you, everybody. Thank you, Jesus.
Thank you, Alex. Yeah,
thank you.
Have a nice break and see you soon.
Exactly. Yeah. Have fun and good rest of the week, everybody.